This is the new Intuition fryer. It's a gas unit. It differs slightly than the old systems we've had over the years. In this system, basically, on a full vat system, each burner is independent. In other words, we have two fans, we have two modules. They're basically independent operation-wise. So a full vat or a split vat are basically the same scheme of things. When you look down the flue, what you'll see the actual flue split. This helps us with combustion, along with the fans. The fans themselves go through a self-check, and they adjust themselves every 24 hours or whenever power is turned on to optimize the airflow. This coupled with the gas pressure gives us a good burn. And over time, the fan will adjust for the filter getting clogged up or differences in atmosphere or whatever. So it's very, very sound system. Now, the other thing that the fan check does is that when the filter gets clogged, which is like 95% of the fan's capability, it'll bring up change filter or clean filter. So there is a filter on here to be changed and cleaned. So we'll start there. Being how the burners are split and independent, we have two gas valves on all fryers. Even the full vat will have two gas valves. The left and right burner systems are two independent burner systems, whether it be a full vat or a split vat. Is our normal standard high limit that we've been using for years. It is common. The igniters, if you notice the igniters, there's no enrichment tubes on them. We've done away with enrichment due to the way we control the fan and the gas and the chambers. Enrichment tubes are no longer needed. This means that the igniters are universal for all different gases. We have pressure switches. We have two pressure switches because we have a left and right burner system. We have two pressure switches. Pressure switches have basically perform two functions. One is the fans will calibrate to the pressure switch, and that way we can repeat how much air pressure we're having in every time. And the other thing is, for certain agencies around the world, they do have a pressure switch as part of their requirements. The pressure switches are very similar to the ones we've had in the past, where the power passes through the pressure switches to run the heating system. Okay, as far as the probes go, the Cook probe, the ATO probe, and the AIF probe, all three probes are identical. In other words, you have a probe here that has a short lead and has a white plug on the end of it. All the plugs are the same. They're identical. All three probes plug into the one harness. This is the main harness that plugs into the back of the HCB, and this is the pin out for it. It just plugs into the back. The OIB's here. It's different than our old OIB. It has a smaller heater in it. It stays cleaner. It operates differently than the old one used to. It plugs right into the back of the HCB. There are no additional boards or relays. The OIB actually works on the temperature rise, and it also looks at the temperature of the Cook probe as far as the range goes. The biggest thing is the temperature rise. When it's in free air, it rises quickly and it'll shut down. When it's in oil, it rises slower and it realizes oil is there. The controller has a cooling fan on it here, and this fan can be easily replaced with a screw, and it just plugs into the back. The actual molding has a chimney with a tortuous path that fresh air comes in. It's drawn through the controller to cool it, and then it exits the fan. If this fan fails, it will come up and there should be an alarm that the fan has failed. The controller can still operate, but in excessive temperatures it will shut down. This fan is to ensure reliability in all environments.